Others just give your intro and also just defining the for which PSUs you want to prepare and snap for which subject you want. You know?
Yes, sir. Sir, I am Adarsh. My name is Adarsh Singh Thakur. I did my Bachelor's of Engineering in Civil Engineering from Jabalpur Engineering College, Jabalpur. After that, I did my Master's of Technology from IIT Gandhinagar in Geotechnical Engineering. And in my MTech thesis, I published 2 research papers, and the topic of the research papers were dynamic behavior and characteristic failure response of low plastic cohesive soil. And presently, I am working in National High-Speed Rail Corporation as a senior executive. And during my tenure at the organization, I was looking after the construction of pile foundations and geotechnical investigation. And I've also inspected the tests related to geotechnical investigations such as pilot test, and along with that, pile integrity test, cross-hole sonic logging test. And along with that, I was given the responsibility of development of Asia's biggest geotechnical laboratory. And one of my favorite subjects is strength of materials. So I would like to have the snap of that subject along with transportation also.
Okay, so just tell me why we use the Castiglione theorem. So how can we differentiate in which case the Castiglione theorems will be used, in which case the movement area method used, or the double integration method used?
Castiglione theorem we can use in such cases where we have a like in 2 cases where we can have a deflection at one point and a load applied at another point in 2 beams. Like in a single beam, if a load is applied and deflection we know at other point, and then other beam if the load is applied on the beam wherein first deflection was given, so we can apply Castiglione's theorem to find out the deflection in the second beam. And in case of moment
Vijay Meena, एक मिनट just hold down Adarsh. Vijay Meena, please join at the 2-7 है ना?
2-7?
Yeah. 7 मिनट बाद join, 10 मिनट बाद join कर लेना आप.
Okay, sir.
Okay.
I can leave now, sir?
Yeah, you can leave now. Yes. Okay, Adarsh.
Yes, sir. In moment area method, we can use when the rigidity of the beam has been given in, like if a single beam, if it is having a different rigidity into length of its beam, then we can use moment area method. That will be easy for us to calculate the deflections at in that kind of beam.
Okay. So can you just tell me, have you ever studied the pressure vessel?
Yes, sir.
Thin cells, I'm just talking about. So
yes, sir.
Midun Das, please join at the 2:15, and you can leave now.
Okay, sir.
You can leave. ये थोड़ा सा डिस्टर्बेंस इसलिए हो रहा है, 3 बजे का टाइम है स्लॉट का. मैं तुम्हें पहले लेना चाह रहा था, 2-4 मिनट लेट हो गए, बट नो इशू, है ना?
Yes, sir.
Okay. Just tell me the pressure vessel design.
Yes, sir. Yes, sir. Pressure vessel, sir. We are using LPG cylinders in our home. It is considered as a thin pressure vessel, and we can also have a balloon. If we will see, it is also a thin pressure vessel. So these are the examples which I have seen.
How the stresses are acting on that? Main thing is that.
In case of pressure vessels, the main stresses that are acting is the hoop stress. Like the internal pressure was applied on the thin pressure vessel in the terms of tension at the, like if you will cut a section of a thin pressure vessel, then there will be a tensile applied due to the internal force applied on the vessel. If you will cut a vessel in a half, then the internal pressure that has been applied on it can be calculated as the hoop tension that has been applied on the surface of the pressure vessel. And the radial stresses are kind of taken negligible in case of thin pressure vessels because the thickness of the thin pressure vessels are quite.
How can you define the column?
Column, we can define it as a compression member. So it is basically a compression member, and if it is having a length to width ratio greater than 12, then we can define it as a column. Otherwise, lesser than that, we will go for no, lesser than that, we go for short column and long column. We can define that way. If L by D is less than 3 or 4, then we can define it as a pedestal. And tension is a compression member. So a load is applied as a compression load is applied in a compression in the column, and it may fail due to the buckling of the column, or it may fail due to the crushing of the column also if the length to width ratio is quite low in that case.
What do you mean by crippling load, and what is the formula of that?
Crippling load, we can calculate the formula of crippling. The crippling load is basically a load which is lesser than the elastic load, in which the column fails in buckling of the buckling. And the crippling load, we can calculate that the formula is that pi square EI upon L effective का whole square.
Okay, pi square EI upon L square, है ना? So here the one term is also known as radius of gyration. What do you mean by radius of gyration?
Radius of gyration is a term that we can use to calculate the moment of inertia of a body through a certain axis if the whole of the mass has been considered at a single point of that body. So the distance that we can calculate to find out the moment of inertia, that is termed as the radius of gyration.
Okay, what is the moment of inertia of a disk?
Pi d square by 64.
Mass moment of inertia?
Mass moment of inertia mr square by, I think, 4. I don't remember exactly, sir.
Okay. What do you mean by strain energy?
Strain energy. So when a load is applied on a body, so certain deformations has been taking place. So to resist those deformations, the energy given by the material to resist that strain is known as the strain energy. And it can also be calculated as the per unit volume. We can define it as the area of a stress strain curve.
Okay, just tell me how to find out the strain energy when it is subjected to a movement. Let us assume there is a one cantilever beam which is having the movement at their free end. Just find out the strain energy. How can we find out the strain? Just tell me the method.
Yes, sir. So basically, we can find out energy due to movement. So that is can be calculated as half into movement into that theta, that whatever be the rotation that has been produced in the body. So strain energy per unit volume will equals to half into movement into theta. So in that way, we can calculate the strain energy.
In this case, you can find out by this way.
Yes, sir, we can. There is another method also by using our students also we can find out like strain energy. The deflection has been defined as the del u by delta. It is has been defined as the from this by integrating it we can find out the equation of a moment and theta like d2 by over dx square equals to m upon ei. By using this we can find out the dy by dx, and after integrating it we can find out the strain energy.
Manish,
Yes, sir.
please join me at 225.
Okay, sir. 225 या 325?
Sorry, 325.
Okay, sir.
And hello, sir.
हेलो अपना कैमरास ऑन कर दीजिए आप एक बार.
सर मैं गौरव बोल रहा हूँ.
अरे हेलो गौरव सर.
हाँ सर, आप भी सोम का ले रहे हैं क्या मॉक?
नहीं, मैं सोम का नहीं, एक्चुअली मैंने तो एनवायरनमेंट का स्नैप लेना था 3 बजे. आपके लिए क्या ये वाली आईडी आप यूज कर रहे हैं अभी?
हाँ 3 बजे तो सर मेरा था इसमें.
अच्छा, मैं एक बार मैं बात करता हूँ एक बार गुरुंदर सर से.
हाँ ठीक है.
ओके.
Adarsh?
Yes, sir.
Just tell me what do you mean by fatigue load?
Fatigue load, sir, we can define the fatigue load as the cyclic loading applied on a body for a certain long period of time. So the stresses that has been developed due to this cyclic loading can be termed as fatigue loads.
What do you mean by resilience?
Resilience we can define as the proof stress, like resilience we can term as the strain energy that has been generated in the body up to the elastic limit. So before the elastic limit, whatever be the strain energy generated can be defined as the resilience of the body.
Abhinav, please join me at 3:35.
Okay, sir.
Okay. So थोड़ा सा disturbance हुआ, but I was just listening about your answers. So Adarsh, I will just give you the feedback. Overall, you are really good. You have a way of talking is also good. आपका जो आंसर देने का तरीका है वो भी अच्छा है. आई कॉन्टेक्ट्स बना के और फुल कॉन्फिडेंस से आप आंसर दे रहे हो. That is a good thing. Or even though you have a smiling face, so that's also collect so many positive points. So that thing keep on your interview also. है ना? बाकी
Yes, sir.
अच्छा है, कोई दिक्कत नहीं. कंसेप्ट में थोड़ा बहुत मुझे डिले लगा. कास्टिलोगेंस थ्योरम्स आपको प्रॉपर तरीके से नहीं पता, स्ट्रेन एनर्जी प्रॉपर तरीके से नहीं पता आपको, है ना? और ऐसे छोटे मोटे पॉइंट्स है जो आपको एकदम एग्जैक्टली नहीं पता. आई एम नॉट सेइंग दैट यू आर नॉट नॉलेज अबाउट दैट, बट कहीं लैग कर रहा है, तो उस चीज को थोड़ा सा रिवाइज करो एंड यू विल बी गुड इन ओवरऑल.
Yes, sir.